Hello, 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 guys. So let's see today GFG POTT solution once again. Early in the morning that I upload the solution that is also got accepted at that time, but due to the error in GFG, that code is not working right now. So one of you message comment on my video that it's not got accepted. So let's see again that what the question want to say and how we have to change the code so that it got accepted. And at the end of the video I will also show you the solution that is correctly working in the morning, but right now that is not working. Okay, so we have given an array of integers, and our task is to count the number of ways to split the array into two disjoint groups. That means that no two elements should be in the both the group. Both groups should have different elements, and it says that zero both the elements of group is equal. Answer is very large, so we have to return 10 to the power 9 plus 10 means it should be in our integer range. Like in this example they are given us that 1 2 3, and 1 can be obtained by taking the jour of 2 and 3. Similarly 2 obtained by 1 and 3, and 3 obtained by 1 and 2. And in 5 to 3 2 they are saying that we are not able to obtain any kind of group that have same jour both of them, and we have to do this in time complexity big of and space complexity big of 1. Okay, so let's see them that how we can do this question. Okay, so first I have written here the condition of and Jor that if both elements are different, then the Jor obtained is 1. Okay, and if the both the elements are same, then the Jor obtained is always 0. So let's first see the example, and then we move to the code part. Okay, so we have given the example of 1, 2, and 3. Okay, so we have to split this if we I talk about the general that if I have a G group, okay, and I have to divide this G group into two G1 and G2. Okay, so it have two element that G1 and G2, and both contain all the elements. So let's say it jor is XR1. Okay, and its jor is XR2. So we are saying they said us that both jor should be same. Means if we take the jor of both the elements, then that jor it comes out to be 0. Okay. So how this jor come out to be? Because if both of them same, let's say we are taking an example here. Let's say we take example of both XR1 and XR2 are 3, then the bit representation of both is 0 1 1 and 0 1 1. Okay, so 0 and 0 both are same, then 0 1 and 1 both same, 0 1 and 1 same 0. Okay, so from here we can easily see that if the elements are same, then the jor should be 0. So from here we can come to a condition that if the complete jor of the array is 0, then we can only obtain the two groups G1 and G2 that can have same door. Otherwise, that can not be obtained. Okay, so let's focus again to our example. Uh, okay, so it is 1, 2, and 3. 1, 2, and 3. And the bit representation is 0 0 1 of 1. For 2, it's 0 1 0, and 3 should be 0 1 1. Okay, so we have to split this complete array into two parts. That first one is G1 and another one is G2. Okay, and the jor of both should be same. Means the collective jor of both of them must be 0. Okay, so let's as we know that one can be obtained by taking the jor of both of these 2 and 3. 2 can obtain by 1 and 3, and 3 can be obtained by 1 and 2. Okay, so we are obtain these element because the complete jor of all the elements here is 0. Okay, so as you see from the second example that they are given as that 5 to 3 2. Okay, so in that we are not obtaining the jor to be 0. We are not obtaining the two groups that should have same zone. Okay, so we have 0 because we can't obtain one element from the other elements in the next group. Okay, so here we are obtaining 0, that's why we are able to see that one can be obtained by 2 and 3. So let's divide it into the two groups. Let's say first contain 1 and 2. let me erase this manually, right? I have to. Okay, so let's say first one contain 1 and 2, and the second group contain 2 and 3. Okay, yeah. Okay, so second group contain 2 and 3. Okay, because 1 can be obtained by 2 and 3, so it is the first group, and the second group can be that 2 can be obtained by 1 and 3. Okay, the total number of groups that you are worrying about, that how many groups can be made, is 2 to the power 3. Okay, because we can take an element in either of the group, we have two options. Okay, so 2 to the power is 3 is 8. So total 8 group we can make from this. So two group are in front of you, and the next group is 3 and 1 and 2. 3 1 and 2, and the other three group that you can be obtained by flipping that g1 here, and g2 here, and g1 is here. So three are these, and three that the same group that you obtained. So total groups you till now obtained is 6. Okay, and one you can obtain that 1 2 3, all the elements are in the one side. So the two groups, and in another one that it is empty, and 1 2 3 on the on the another side. Okay, so it is the next group. So total group that we are obtained till here is 8 groups. Okay, but all the groups are not valid. Like from this you can see that these two groups are not valid. These two groups are not valid because in one of the group there is no element is present. So from the total groups 2 keep power n, what we have to do, we have to subtract 2. Okay, so we have to subtract 2, then we obtain these groups, and in these group each group is present 2 times, so we have to divide it by 2. Okay, so what it's become, it's become 2 to the power n minus 1. Okay, 2 to the power n minus 1 minus 1, and we can obtain that 2 by left shift. Okay, so if we left shift the 1 by n minus 1, then it become 2 to the power 1, 2 to the power n minus 1, and we have to subtract minus 1 from this. And for it to be in an integer range, we have to mod it. Okay, so we have to mod it. This is the solution that is corrected. In the morning that I observed that I am supposing that for 1 only 2 3 percent, and for 2 only 1 3 percent. So that is running fine for the this test case, and also running fine for all the test case I am showing you. But that is not correct and not running now also. So thank you for like viewer said me that it is not running. So thanks to that. And so let's see the code that what we have to do. Okay, so let me see in code. So it is the code that first we have to calculate the jour of all the element, and if we obtain the jour of all the elements is 0, then we have to return 2 to the power n minus 1 minus 1 modulus mode. So it should be in the integer end, and if that is not possible, then we have to return the 0. Okay, so this is the solution. So let me compile it and submit it, so that you can easily see that all the test cases are running or not. So it's a like a tricky question that we have to take in mind. Okay, so this is running fine. Let me show you the code that I am written morning. So I have accepted the solution on today on 7:18, like 7:18 a.m. And you see the code that is also running fine. And I am seeing you this code in the previous video, but that is not running fine. It is also incorrect, but that is got accepted. So I made the video and showing you this code. So sorry for that, and now you can easily understand from this code. So thank you.